Okay, for today, we're only going to cover 3 questions in your exercise 2.3, which will only be question 1, 2, 3, I think, which is only page 94, 95, and 96. Why? Because question 1 will take you a little bit of time. So what do they actually want from question 1? So if you look in your manual, for each diagram, find the equation of the regression line, correct it. So you're going to find the equation, predict the value, find the residual for each A and each B one by one. So in this slideshow here, I'm going to start with diagram A. So diagram A, how do you basically find the equation of the line? You need to actually extract out all the coordinates one by one, as you see in my slide here. Okay, you take out all the coordinates one by one. So basically you have 1, 6, do you see that? 1, 9, do you see? 2, 7, okay, then you will have a 3, 3, 6, 3, 7, 3, 8, 4, 7, etc. You go on and you will put down everything into basically the, you'll put down everything basically into the table down there, as you see, sorry. Okay, then you will find the line of best fit using your calculator. Plug all those x and y into your calculator. They've already drawn the diagram for you, so you know this is y, this is x. Pretty much you know the coordinate x, y, right? So you make sure you put it in the right order, 1, 6, 1, 9, and you should get the line of best fit here. The line of best fit should always be in 4 decimal places, but in this question, no problem, because they've asked you in 2 decimal places, you just follow, no problem, okay? Now they've asked you to find the predicted value for x equal to 9. How to find the predicted value when x is equal to 9? You plug 9 into this equation here. Can you see that? Okay, you plug 9 inside here, you will get 3.1. Okay, now they ask you to find residual associated with this predicted value. How to find the residual? Okay, when x is equal to 9, what do you get? 3.1, isn't it? Okay, so this is what this predicted value is 3.1, isn't it? Actual value is 4. So 3.1 minus, basically you have to minus it. Take the actual, which is 4 minus 3.1. Understand? Actual minus predicted. That's how you get 4.9. Again, how to find x when x is equal to 9? You plug x equals to 9 into the equation, you get 3.1. That's the predicted value. How to find residual? You take actual minus predicted. The actual when x is equal to 9, the actual is 4. Therefore, you take 4 minus 3.1, you get 0.9. That shouldn't be a problem. How to find the largest residual? There's no other way. You got to do it one by one. Put it into the table like the way you see it in my slide. And then you find the one with the biggest residual there. So the biggest residual there you will see is 0.53, okay, which is negative 2.14. It doesn't matter if it's negative or positive. I just want to know how big is the difference. Okay, it doesn't mean a negative value, oh, very small, actually not big. No, it's not true. Okay, so that is how you basically do it. Are we good here? All right, so it I think shouldn't really be a problem. I want you to sort this out, okay? Okay, so for part B, we're going to do the same thing. Exactly the same thing. You take all the coordinates one by one, you write down the coordinates, put it into the equation and find the predicted values, because later you need to find largest residual. So if I were you, just fill up the table one shot lah. Okay? Predict the value for x equals to 9. X equals to 9, plug it into equation, you should get the value of 4.38. What's the residual? You go to x equals to 9. Original value is 4. Actual minus predicted. 4 minus 4.38. Your residual this time is negative 0.38. So you're basically doing the same thing. I wouldn't expect any problems here. Okay, but if you compare between part A and part B, right? What can you see from part A and part B? Which data is better? Part B's data is better, right? Because the total residual is smaller. Okay, so now we're going to do question 2. A class of 15 7-year-olds, so you know there's 15 sets of data there. The scores were out of 10 were compared with the month of their birth. So what are they saying? When the month is 1 is January, month is 2 is February, when it's 3 is March, like that lah. When it's 4 is April. Okay, so find the regression line. This is what I want you to highlight in your question. Find the regression line for predicting the test scores from the month of birth. Whenever you see this, right, you see when you want to find regression line, you must put it in the right way. This is what I meant. Sometimes they don't give you X and Y, but here still got Y, still is quite okay lah. Sometimes the Y not necessarily is Y, you understand? So predicting the test score from the month of birth, whatever you want to predict takes the position of Y. Take the position of y, all right? Like your y equals to a plus bx, that y I'm talking about, okay? It takes the position of y, meaning when you look at a coordinate is x comma y, that y I'm talking about. So sometimes they won't directly tell you y against x, like just now. Sometimes they'll tell you find the regression line for predicting the test score. So what you want to predict is y. This is what I want you to put in your head from the month of birth. So now you need to put it into your calculator. 1, 9. 2, 9, 5, 5, put it into your calculator. Okay, so you will get it in, make sure you put it in 4 decimal places. This time the question didn't ask you to put it in 2, so you have to follow accordingly. All right, so why do you see the little thing on top, y hat? Because this is predicted. So from now on, I want you to get used to using that term with the hat on top there, all right? So y hat is equal to 8.5741, a plus bx, so 8.5741 is your y-intercept minus 0.5012 m. From here, what can you see? If your gradient is negative, your r must also be negative. Do you understand? Okay. All right. Okay, so find the r. If you've already put it into the calculator, your r is there. If you haven't cleared your data, your r should be negative 0.7. They ask you to comment on the relationship. Just follow the scale we have learned before, moderate negative linear relationship. You can even write between m and y, no problem. If they ask you significance of relationship, how to answer? M increase, Y decrease. I even accept that. You don't have to write it in full like months increase, score. Sure, come up for exam 1 because students always make mistake. They always only remember how to comment. They always forget what is significance. Understand? So commenting is following the scale that you are given. Significance, use common sense. Positive, one increase, the other one increase. Negative, one up, one down. So like this is negative. You can even write M with the arrow going up, Y arrow going down. No problem. Months increase, score decrease. Easy. Predict the test scores for a child born in April. How do you predict the test score for a child born in April? April is what? January, February, March, April, 4, right? M is equal to 4, right? So you plug 4 into the equation that we found earlier, meaning the y equals to 8.5741 minus 0.5012. That M there, you will be 4. So you find what is y? You will get 6.5693. 6.5693, you will round it off approximately to 7. Why? Because if you look down there, the scores are all rounded off. There is no decimal, so you round off to 7. Okay? Now, if the child had been born in November instead of April, would you expect the test score to be lower or higher? This is following your relationship. Your relationship is negative, right? Months increase, score decrease. So if you go to November, that means as the months increase, the score should be lower. So score will be lower. As your R is negative 0.7, it shows that months increase, score decrease. Okay, so question 3 will be the last question that we're going to do for today. So from what you can see here, you're not given X and Y now. Now it's T and M. How do you know which is X, which is Y? Okay, I already told you. Okay, now, first of all, the mass can dissolve in one. So what we're talking about, the amount of salt that can dissolve in water. All right, so always read the question, okay? So they've given you the temperature here. They've given you the mass here. So determine the value of correlation coefficient between the mass and temperature. When you're finding correlation coefficient, whether you put T first or you put M first, it really doesn't matter. You can try. If you don't believe me, you can put 20, 7.2, 25, 8.5, or you can put it vice versa, the other way around. You will get the same answer. Okay, this is where students always go wrong. But when it comes to the least square regression line, you have to put it in as a coordinate. What's a coordinate? X comma Y, meaning X variable goes in first, then Y. If you don't do it that way, it will be all wrong. So if I were you, before you start the question, identify which variable is X, which variable is Y first. and write it down in the table, so you will never go wrong. Because if not, you have to input the data twice. Why do you want to do that? Input the data once but do it correctly. Okay, so the correlation coefficient question, you already know, is not going to tell you which is x and which is y. Which one will tell you which is x and y? Your least square regression, your line or best fit. Line or best fit, least square regression line, they all mean the same thing. So least square regression line is your y equals to a plus bx line. Only this, like just now we saw predicting this from this. What you want to predict is y, right? Correct? Then initially we saw y against x. Then you already know how to see. This is the last way. There's only 3 ways they will actually ask you in the question and tell you which is x, which is y. The last way is this, m on t. What does m on t tell you? Imagine the graph. What is on top there? Y, isn't it? What's on the bottom, on the horizontal line? On the bottom, there is x. So m on t. M will be y and t will be x. This is, if I were you, label it into the table. M is y, t is x. So when you put it into your calculator, it will be correctly done. In this case, I've given you x, y, up, t and m on top. In your exams, you will get it the other way around. M will be on top, T will be on the bottom. Because students are so good at overlooking this part. They will just put it in the way they see the table. So you cannot do that. You must identify which is X and Y, and when you put it into your calculator, it should be in the right order. Okay, so M on T, M is Y, T is X. If they tell you A on B, A is Y, B is X. Predicting A from B, A is Y, B is X. So don't forget that, all right? So let's put it into your calculator. So you do it once and for all. That shouldn't be a problem. Okay, M on T means predicting M using T, which is, I already explained to you. So when you put it into the calculator, your R will be 0.97, which tells you it's a strong relationship. It shouldn't be a problem. Your line of best fit will be in 4 decimal places because the question didn't state otherwise. So you just follow the rules that you have been using. Okay, use this least square regression line. Don't panic when you see such term. Least square regression line, line of best fit, all same thing. To estimate the number of grams of salt that would dissolve at a temperature of 40 degrees Celsius. What are they telling you now? T is equal to 40. So if T is equal to 40, what is M? So you just put 40 into the equation. You just substitute 40 into the equation. You will get 14.0047 grams. Okay, why do you, after that, please write it in 4 dp first. You will see why later. Always write your answers in 4 decimal places, then you round off. Why we round off to 2? Because this one got units, your answer must be in 2 decimal places. We have been using this rule since semester 1, shouldn't be a problem, okay? So comment on the accuracy of prediction. I taught you accuracy already. Only got 2 ways, right? Interpolation or extrapolation. Okay, so now, is this interpolation or extrapolation? What do we look at? Temperature, right? They ask you to predict 40 degrees. Temperature is your X. Is 40 within the range? The smallest value is 20. The biggest value is 50. Is 40 within the range? Yes, 40 is within the range. Therefore, this is an interpolation. Therefore, it is somewhat accurate. I taught you this in the previous slide. Only very standard. No, you can write it in 2 points. Interpolation, first point. Second point, somewhat accurate. You get full marks for it already. Okay, accuracy of prediction is always standard answer. All right, you look whether it's interpolation or extrapolation. Number 1. Number 2, somewhat accurate or not reasonable. Interpolation, somewhat accurate. Extrapolation, not reasonable. In this situation, your temperature is 40 degrees Celsius, is within the range of T, right? 20 and 50 is within, is inside them. So it is interpolation. Right. Continuing on. Okay. All right. So we got that. This is just the same thing actually. So find the residual. How to find residual? Actual minus predicted for a temperature of 50 degrees Celsius. How to find residual first? You already got the actual value in the table, isn't it, before this? But how to find? Okay, you first of all need to find the predicted value. So when T is equals to 50, what's your predicted value? You put into the equation, you will get 17.8407. In other words, 17.84 grams. All right. So how to find residual? Actual minus predicted. Where to find actual? Go look into your table. It's there. 19.5. When the temperature is 50 degrees Celsius, what actually or really happened is 19.5. Minus what you predicted. Always do it in 4 decimal places. This is what I meant by writing your answer in 4 decimal places first, then rounding it off. Because if you don't minus in 4 decimal places, your answer will be different. Okay, so 19.5, what actually happened, whatever you see in your table, minus your predicted value, you will get 1.6593. Okay, which is in other words 1.66 gram. What is the significance? Significance is what? If your residual is positive, what happened? If your residual is positive, actual is more than predicted. That's it. You can write it just like that. Positive, comma, actual more than predicted. It's full marks. Okay? Now, find the correlation coefficient between volume of mass dissolved and temperature. Now, between mass and temperature was 0.97, right? So between volume and temperature, it will be the same thing because you're talking about the same salt. Okay, whether I'm talking about mass, density, whatever, it is the same salt. So the relationship will be the same. It will still be 0.97. Just like if an example, I take your body weight and how fast you run. Okay, and I take your body density and how fast you run. Your correlation coefficient won't change because it is still you running. So it's the same thing in this example. Your mass of salt and temperature is 0.97. The volume of salt and temperature will be the same. Why? Because it's the same salt dissolving in the water. Density of salt and temperature will still be, it won't change because it's the same salt. You understand? Okay? It's the same as this. Another example to this is, if I take the mass in kg and the mass in gram, it will be the same relationship because it's the same salt. It's only different units, that's it. Okay, so you will see many questions like this in your exam. What is the correlation coefficient between the volume of salt and mass dissolved? Anything related with the formula, the relationship is perfect. The only thing that you need to think whether it's negative or positive. I'm repeating this. Anything that has a formula, okay, like A plus B equals to C. So the relationship between A and C, B and C is all perfect because there is a formula. Okay, only now you have to use your common sense and think whether it's positive or negative. So if you look at the green box there, do you see mass over volume equals to 1.2? That is obviously a formula, right? Anything that is in the formula, you know it's perfect relationship. Now use your common sense. If volume of salt increase, will the mass increase? It will increase, right? If the volume of salt decrease, the mass should also decrease. Therefore, this is a positive, perfect relationship. Okay, so anything related with the formula, perfect relationship. Whether negative or positive is the second level. You think about it. Understand? If one increase, the other one increase, positive. If one decrease, the other one decrease, positive. Positive relationship, they move in the same direction. Okay, so we will stop here for today.